Welcome back, Algebra 2. So this is part 2 of how do you transform a function, and in this one we are going to do cubics and square roots. So I have I have my general form. A we are not worrying about today. So remember, H tells you how much a function goes right or left, and your X always lies to you. And then K tells you how much it goes up or down. On my cubic function, I have x minus 2 squared plus 1. The minus 2 is my h, because I can look up here at the general form, and that's my h. And then the plus or minus number at the end, that is my k. And you also have to remember that h and k work together, and they tell you the vertex. But in this section, I call it the starting point because it's not really a vertex, but it is kind of the main starting point that I use. Your x always lies, so my starting point is at 2, 1. Now describe the transformations. So if you are minus 2, that means you went right 2 units. And if you're a plus 1, you went up 1 unit. The cubic, hopefully you remember, is this kind of a weird S shape. There's not the same kind of symmetry as there were on the last two functions. So on this one, you have to plug in all your x values. That is a definite difference here. I am going to use the vertex, or aka starting point, as my middle value. And then I am going to do the same thing. I'm going to choose two values smaller, so that would be a 1 and a 0, and two bigger. That would be a 3 and a 4. I'm going to run out of room. Okay. I'm going to plug all these x values in, and then my answer is going to be their y value. So when x is 0, I have 0 minus 2 cubed plus 1. 0 minus 2 is negative 2. Negative 2 cubed is negative 2 times negative 2 times negative 2. So since you have an odd number of negatives, you still have a negative number. This is negative 8 plus 1. Which equals negative 7. Now I'm going to plug 1 in for x. 1 minus 2 cubed plus 1. 1 minus 2 is negative 1. I have an odd number of negatives, so I still have a negative 1 plus 1, and that adds up to 0. You could plug 2 in, but you'll get 1 because it always works for the vertex. Now I'm going to plug 3 in. 3 minus 2 cubed plus 1. 3 minus 2 is 1. 1 times 1 times 1 is 1. Plus 1 adds up to 2. There's my y value. Plug 4 in. 4 minus 2 cubed plus 1 is 2 cubed plus 1, and 8 and 1 adds up to 9. All right, I'm going to go plot these points. 0, negative 7, 1, 0 is right there, 2, 1, 3, 2, and 4, 9. So I'm just going to kind of connect the dots and sketch it in as best I can. And that looks pretty reasonable today. So the domain and range are completely different on this one. Domain is what x values could you plug in here? Anything that I wanted, so therefore it's negative infinity to positive infinity. The range is your y. So I have this tail pointing down. So that's saying this is going down to negative infinity. And I have this other tail pointing up. So that's saying that one's going to positive infinity. So the cubic range goes from negative infinity to positive infinity also. To find the x-intercept, you look and see where the graph is crossing your x-axis, and that's at 1, 0. Or you look when the y is 0, there's your x-intercept, so it's at 1, 0. Your y-intercept, you can look on your graph and see that it's crossing right there at 0, -7. So that is how you transform a cubic and find its vertex. And finally, let's do the square root function. So the square root function, it generally has this kind of a shape to it. And you have to remember no negative number under your radical symbol. You cannot take the square root of a negative number. So this one is also going to change the x values that I select. All right, let's start off and figure out where the starting point, aka vertex, is located. So there's my h and there's my k. So I don't care whether my grouping symbol is parentheses, absolute value, or a radical. They all still work the same way. So -3 is my h, and your x always lies to you. So that's +3, and then your k value is 4. So that's my starting point. My transformations. So if you're hanging out with the x, that tells you your left-right movement, and -3 means that I go right 3 units because your x lies to you. And the +4 at the end means that I'm going to go up 4 units. So since I'm going to end up taking the square root of a number, I would like to choose values that are perfect squares. My first couple perfect squares are 0, that's supposed to be a 1, 1, 4, and 9. So I'm going to choose x values that add up to these. 3, 4, your starting point is always going to be your first value. Because if x is 3, 3 minus 3 equals 0. And then if the square root of 0 is 0, plus 4 is 4. Now you need to choose an x value so that this adds up to 1. Blank minus 3 equals 1. Well, that would be 4. Now I'm going to choose an x value so that it adds up to 4. Blank minus 3 equals 4. Okay, so that's 7. 7 minus 3 is 4. Now you want to choose an x value so that this adds up to 9. Blank minus 3 equals 9. And that would be 12. All right, so I'm going to plug these values into my function. So I have the square root of 4 minus 3 plus 4. 4 minus 3 is 1. The square root of 1 is 1. Plus 4 equals 5. So that y value is 5. Now I'm going to plug 7 in for x. The square root of 7 minus 3 plus 4. 7 minus 3 is 4. You have to remember to take the square root before you add it. The square root of 4 is 2, and 2 plus 4 equals 6. And then you're going to plug 12 in. The square root of 12 minus 3 plus 4. 12 minus 3 is 9. Take the square root of 9, which is 3. And 3 plus 4 adds up to 7. Now you need to go plot all these points. So 3, 4, start at the origin. write 3 up 4, plot 4, 5, start at the origin, write 4 up 5, 7, 6, 7, 6, and 12, 7. Go off the graph a teeny tiny little bit, and there's 12, 7 approximately. This is not a straight line, it is a curve because it's a parabola on its side. So that's what the correct graph looks like. Domain are your x values. So your x values are very different on this one. You're not allowed to have a negative under the radical, and so this vertex, this starting point, that helps you see what your domain is. So the smallest value you were allowed to plug in was 3. And then if you look at your table, you can see that my numbers are getting bigger and bigger and bigger. So my domain goes 3 up to positive infinity. You could also look at your graph. So it started here at 3, and then it kept going bigger and bigger and bigger. Your range is what y values do you get out of this? So the smallest y value I get is 4, and then you could look at the table and see they keep getting bigger, 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 bigger. It's a little bit harder to see on this one because it looks like it's going to the right, but it's going both up and to the right. So my range is going from 4 to infinity. Your x-intercept, where does your graph cross the x-axis? It does not. None. Where does the graph cross the y-axis? It does not. That one is also none. So if it shifts in such a way, it might not cross either of them. So that is how you graph square roots and cubics. Thank you.